Hi, in this video we will use the area assumptions that we discussed in a previous video, and using only those assumptions and logic we will compute the area of a rectangle whose side lengths are 4 and 3 units, and then we will use this argument to arrive at a general theorem which gives us the formula for the area of a rectangle whose side lengths are any whole numbers. So let's look at what I have here. We would like to first look at a rectangle whose side lengths are 4 and 3 units. So it's very convenient to start with a number line like this, horizontal number line and a vertical number line, and place a rectangle in this manner. So here I've marked off the unit segment on both the horizontal number line and also the vertical number line. So here this length is 4 and this length is 3, and so here's my red rectangle whose side lengths are 4 and 3 units, and I would like to know what area, what number should I assign to this rectangle and call it the area of the rectangle. By the fourth assumption, it says if we were to partition this rectangle into smaller regions in any way you like, and my choice is to partition using this vertical lines and horizontal lines in this manner. If we do that, then the fourth assumption says the area of this big rectangle better be the sum of the areas of all of these smaller rectangles. In fact, each of the smaller regions is a square. And by assumption 2, the area of each of these squares, which we recognize as a unit square, must be 1. So that means the area of each of the smaller regions is 1 by assumption number 2. And assumption number 4 tells us the area of this rectangle better be all of those number of ones added together. How many of those do we have? From the picture it's very clear. It is 4 times 3. So the area is 4 times 3 or 12 square units. Now even though here I have used specific numbers 4 and 3, the same argument holds true if you were to change the numbers 4 and 3 to some of the whole numbers. So that logic leads us to this theorem. Suppose the whole numbers m and n are the length and width of the rectangle. So in this case m and n are 4 and 3, but this argument holds true for any whole numbers m and n. And using that argument, in each case, we can conclude that the area of the rectangle is simply m times n square units. Because if we would partition the bigger rectangle whose side lengths are m and n, whole numbers m and n, in this particular manner, we will place a vertical line at every one of those whole numbers, and similarly on the on this vertical number line also we will place horizontal lines drawn in this manner. If you do so, the bigger rectangle whose side lengths are whole numbers m and n would be partitioned into m times n smaller regions, and each of those smaller regions will be a unit square, which by assumption 2 must have an area of 1. So then that forces us to assign m times n as the area of such a rectangle. And notice this argument only holds true if the side lengths are actually whole numbers. So this is the simplest scenario. In the next video, we'll look at rectangles whose side lengths are unit fractions, and we'll explore that in that video. Thank you.